Hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, implement magic dictionary. So this problem is the next problem in the try series, and in this problem we just have to implement just implement try with a little bit modification. So basically design a data structure which is initialized with a list of different words, again a try. Provided a string, you should determine if you can change exactly one character in this string to match any word in the data structure. That means you want to develop the search functionality in the data structure such that the word you are searching for must differ from the word which is there in the dictionary or try by exactly one character. So basically implement this class magic dictionary here, and in this class we have a constructor magic dictionary. This initializes the magic dictionary or the try or the root node of the try, and this is the insert function which is used to insert the word into this magic dictionary or used to insert the word into the try. Then we have this function build dictionary, which takes in a vector of strings and inserts those strings into the try. Then we have here a search function which checks whether a search word exists or not. How? So this search word which is here in the argument, we change exactly one character in this search word. We have to change it and then check for the changed word if it exists in the dictionary or not. If the changed word exists, then we return true. Otherwise, in all cases, we return false. So we must change at least one, we must change exactly one character in the dictionary. Fine. So let's see how we can solve this problem. So let's understand it using the example. So here we have our example. First of all, we have magic dictionary written here, which means first of all create a object of the class magic dictionary. Then we have build dictionary, means call this function build dictionary and also pass this as an argument, the array of strings as an argument, which contains hello Leetcode. Then implement the search functionality and search for this word hello. Then again search for the word HHLLO. Then search again for HELL. Then search again for Leetcoded. And accordingly return the output either true, false or null. Okay. Only this function search returns a true or false. All other functions do not have any return type. So for all of them we have null as the output or answer. So let's just see how we can solve this problem. So let's take this example to understand it better. So basically we'll be using try data structure to implement this dictionary. This is a special dictionary. So let's see the very first example. We are given that first of all initialize the magic dictionary. So that means in the initialization phase, when the magic dictionary function is called, when the object of magic dictionary is created, we have a root. We initialize a root. Now build dictionary means insert these strings into the dictionary. The strings are hello and Leetcode. So insert hello, insert Leetcode. Okay, so let's insert hello. Do we have h as a child? No. So create h as a child. Do we have e as a child for h? No. So create e as a child of h. Create l. Create l. Then finally create o and mark this o as the ending character. So in this fashion we have hello inserted. Let's insert Leetcode. Insert l. Insert e. Insert e again. Insert t again. Insert c. Insert o. Insert d. insert E, and mark this E as the ending character. Fine, so we have our dictionary prepared or try prepared. Now let's jump to the next command, which is search. Search for the word hello. That means search HELLO. We want to search for a word which is just one character different from this word hello. If it exists, then we return true. If it does not exist, then we return false. Now, here you can see that when we start searching this hello in the try, we find it. We start from the H character, which is the first character of this string. We check whether H is a child for root, which is indeed a child. Now we check for E as a child of H, which is here. We check L as a child of E, which is here. We again check the next L as a child of L, which is here. Then we check whether O is a child of L or not, which is here. That means we have hello word present in the dictionary. So we return false. Let's jump to the next command, which is search for the word HHLLO. Search for HHLLO. That means, so we start from the very first character, which is H. Do we have H as a child of root? Here we have it. Move to the next character, H. Do we have H as a child of H? No. Here we have to change the character. Fine. So we have to change the character. Change this H to one of the child of the H that we have. But here we see H has only one child. H has only one child, which is E. So just replace this H with E. Okay. Now we have replaced exactly one character into the parent string, and it has become HELLO. Now I want to check whether LLO is present as it is in the subtree of this E, which is the character which we have replaced. Fine, so we have replaced H with E as which was a child of H. Now we want to check whether in the subtree of E we find a substring LLO. Now check whether L is a child of E. Yes, it is the child. Move to this child. Now we check again, L is a child of this L. Yes, it is the child. Move to this L. Check for O as a child of this L. Yes, it is the child. Means it is present. LLO is present in the subtree of the character E. So we return true. Okay. That means we had our word, we just replaced one character of the parent string, and the parent string, after replacing one character, was present in the try which we constructed. That means we return true for this search. That's the idea. Let's jump to the next command, which is again search for hell, HELL. HELL. Is it okay? Yes, search for hell. Now check whether this hell exists in the try or not. Like if we change exactly one character, like it is given that we can change one character, we can change or replace. We can't add or remove a character from the string, so we can't put extra character here. We can just change one of the characters of the string which we are given. Okay, so now we are given hell. We want to search for HELL into the string. If we can find a string, if we can find a word which is just one character different from this word. Okay, so let's see that. Do we have H as a child of root? Yes, this one. So move to this H. Now, do we have E as a child of H? Yes, we have E here. Move to this child. Do we have L as a child of E? Yes. Move to this child. Do we have L as a child of this L? Yes. We have found HELL into the root. Okay. And this L is also not the ending word. means HELL is not present. It is not present. So in this case, we return false. And there is basically no way if we can replace one character. Let's just try to replace H. Let's try to replace H with some other character. So let's try to replace H with L. Just replace the character which we want to. So like in this hell, I want to replace H with one of the child nodes for the root node. So here I didn't find my string. So replace H with L. That means for the subtree of L, I want to find this substring ELL. So check for E if we have a child E for H. Do we have E? Yes, we have E. So now go for the next character, which is L here. Do we have L as a child of E? No, we do not have. So as we have already changed exactly one character in the string, we cannot change the second character here. And we finally conclude that HELL do not exist in the trie as we want it to exist. We want it to exist such that we can change exactly one character and the changed word, the modified word is present in the trie. And that's not the case. So the answer is false. Now, check for Leetcode. Check for Leetcode. Leetcode. Start from the very first character, which is L. Check if it is present. It is present. Go to the next, which is E. Check if it is present. It is there. Move to the child. Go to the next character. Check if we have a child as E. Yes, move to that child. Check for T. It is there. Move to that node. Check for C. It is there. Move to that node. Check for O. It is there. Move to that child. Check for D. It is there. Move to that child. Check for E. It is there. Move to that child. And this E is the ending character. Means we can't move. We can't. We also we do not have any child node. We do not have D as a child node for E. It is the last character. If we had any child, not necessarily D, for this character E, then I would have found this word. I would have returned true for this word because I have already found Leetcode. All I need is one more character which is not D. So if I had a child for this node E which is not D, then in that case I would have returned true. But here I will return false because I can't add a character. I can just replace a character. So that means this Leetcode cannot be found in the trie because this is the longest string, and the longest string that we have is of length 1 2 3 4 5 6 7 8, while the string which I want to search for, which I am searching for, is of length 9. So that means it is not there. So we return false for this test case. I hope you got the idea what we are doing. Now let's just jump to the code implementation part, how we're going to code this solution. Let's see that. So this is my magic dictionary class, and in this magic dictionary class, let's first implement a separate class to construct a trie because we want to insert all of these strings into a trie. So create a class for the trie node. In this class we have two variables or two elements. The first is array of pointers children. It has 26 children which are pointing to the corresponding 26 characters, and a boolean variable is end. So let's initialize this children array with false. And And also this is end variable with false. Like initialize this with null basically, because we have null pointer at 26 positions. Now in this magic dictionary class, declare a root node which is, and into this magic dictionary initialize this try node. Then into this insert function, I want to simply insert this word into the try, and these functions are known to you because we have learned these things in the previous videos. So basically start from the node, iterate over the word, check if we have a null pointer, that means that character is not there, so insert that character into the try, new try node, and move to that character, move to that child. And at the end, mark the is end for the inserted word to be true. That means we have inserted this word into the try. So that's insertion. Let's implement this build dictionary function. Now it is easy to implement because we just want to call the insert function for all of the words present in the dictionary which we want to insert. So simply iterate word by word which on the words which are given in the dictionary, and call this function insert for every word. So that's how we have our try prepared at this point. Now let's implement the search functionality. Now how the search functionality is little bit different. We know that we base in the parent word which I want to search for, I have to change exactly one character. Only in that case the answer will be positive. If I do not change any character in the search word, then the answer will be false. So we have to keep track of it. How do we check whether we have replaced a character or not? To do so, we'll use a Boolean variable. So let's create a function. Let's create a helper function, search helper, which takes in the string word which I am searching for. It takes in the node on which I am currently standing. It takes in the index for the word, index for the character on which I am standing. Also, we use another variable which is called is replaced. It is a Boolean variable, is replaced. Why do we use it? Just to check whether we have replaced the character in the string which we are searching for or not. We'll see how this is utilized. Now, in this search helper function, start from this node, find the index for the character on which I am standing, corresponding to the 26 positions that we have in this array which we have declared. That means the index for the character present at this index must be word index minus a. Okay, at this index we want to check if we have a pointer or not. Now iterate over all of the 26 characters, all of the 26 positions. Check if the particular children is present. If a particular children is present, so I'm starting from the node, I'm standing on a particular node. I want to check whether a particular children is present. If it is present, then check if it is the same, if the children is same as we have index here, corresponding to this character word index. Okay, if this current index is same as I, that means the character on which I am standing has been found as a child for the current node. If it is found as a child for the current node, then there is no need to replace it. There is no need to replace it. Just search for the rest of the string. So it is the case like, just let's understand it. The case is simple. Like here I was searching for, let's say, hello. If I have found E as a valid child in the trie for H, so I am at H. If E is present as a valid child, then that means I just want to search for LLO. I just want to validate LLO because I haven't replaced any character till now, HE. I haven't replaced it. I have found both of them. Now I want to search for LLO. That means try to replace some character in this LLO. Okay, that's what I'm doing. So recursively call, that's why I'm recursively calling the same function for this condition. So let's also create a variable here. Let's call it res. Initialize it to false. So res search helper, call the same function for the word, for the current node, for this children, and index plus 1, and pass the is replaced as it is because we haven't replaced the child, or maybe we have replaced the child, we do not know. Okay, we do not know, we just want to keep this is replaced as it is. We just know that we have found the character on which I am standing. Whether we have replaced the character on the previous positions or we will replace the characters on the positions afterward, we do not care about that. We just search for a valid word in the remaining string. Now we don't know if we would replace a character in the remaining string or not. Fine, so this is the first case. Otherwise, else if, that means this character is not the same as the character on which I am standing. Means there is a scope. There is a scope for replacement. Check if we can replace it. If it is the case, then is replaced variable must be false. Means we must not have replaced any character in the previous string which we have traversed. If it is the case, then there is a scope for replacement. So try to replace this character, search helper, with this child, current children, with this child. Try to replace it with this current child, pass the word and search for the remaining string in the subtree of the current node, index plus 1, and pass true here because we have replaced the current character. We have replaced the current character at the index with the character at the index I. Fine. Now, after we have done this, after we have performed either replacement or we have found a valid string in the remaining substring, be it any case, I'm going to check if res is still true or not. If it becomes true, that means I return true from here. Okay. Otherwise, at the end of this function, I return false by default. So let's just call this function search helper into this search function. Search helper, search word node, which is the root node, and the index is 0. It is false. Let's try to run it. Okay, I'm gonna return res here. Return res. Okay, we created a try node. We are basically initializing it with null. That's okay. I don't think if it is a problem. Undeclared identifier children. Why? Okay, it's okay. Okay, it's not current, it's node. We have a bug is replaced. Forgot to write colon. Forgot to add this base case. If we have traversed the entire word, index exceeds the word length, word dot length, and this is replaced. If it is the case, then we want to check if the last character which we have traversed is the ending character. If it is end is marked true, and is replaced is marked true. Let's run it. So let's submit this code. So it got accepted.